Hello, I think we've got Simon here.
Hello.
What have you got for us today, Simon?
Well,
We haven't introduced you yet, but
I'm
introduce yourself first properly, but carry on.
yes, Simon Allen. I was asked to do a little biography, and I'm a maths hobbyist. I haven't got a degree in maths or anything like that. I certainly studied mathematics at school, and at the moment I'm not hearing you. Let's just see what's going
Oh, can't you
on.
hear me? Can you hear
I
me?
can now. Can
Oh,
now.
you can hear me. Okay, all's good. All's good.
You
All's
went
good. As long as you can hear me.
silent for a moment. Yes, and I put in my little biography that I was sort of turned on to maths at school. I had a headmaster, and he came and demonstrated a geometrical proof. He didn't give me the name of it, actually. I wasn't until many years later that I found out what it was called, and it was called Thales' theorem. Just wait, hang on for a second. I think I've got the wrong screen up, and I'll move one screen round and just see where I'm going. Hang on.
Sorry. Take your time. Technical issues aren't a problem.
I think that's better. Right, I should be back again now, I think. Yep. Okay. Right. Yeah. What he turned me on to maths, and it was absolutely wonderful, and that led me onto a whole journey, a journey through lots of things that I started getting interested in. And my big win, I think, was going to my local library. This would have been in the 1960s. And I was curious as a child, and still am really. And I reached up to the magazine rack. And on the magazine rack was a magazine called Scientific American. And I thought, oh, I wonder what's in that. And I pulled off a copy and thumbed through it. And I came towards the back pages. And in the back pages, there was a column. I've found out it was a regular column written by somebody called Martin Gardner. I'd never heard of Martin Gardner. And the title of it was Mathematical Games. And I thought, oh, that sounds fun. And I read one of the columns, can't remember what it was now, but I thought, gosh, this is really stuff. And every month I would be down the library having a look to see what the latest bit of news was. I tried this on my school friends, and said, you know, what do you make of all this? And I have to say that they were completely turned off.
Really?
And not in the least interested.
I think that's what you kind of get sometimes, unfortunately. Not everybody's as enthused about maths as we are.
And so today, what I've got for you is I've got a number trick, and I've got a sort of unusual card trick. And I'm going to explain how both work. But this is an audience participation event. So I think we've got about 150 people watching this. What I don't know is I don't know whether they're 10 years old, whether they're 50 years old, whether they're 80 years old, whether they got maths degrees, or where they are. So I'm taking a bit of a chance because I rather think that maths professors are going to find this rather dull. But if you're still at school, I think you'll get quite a lot of fun out of this. And I'm hoping it will puzzle you a bit. So the first thing I'm going to do is to do a bit of mind reading. Scary stuff.
You're going to be reading my mind.
I'm going to read your mind. Now, a couple of things we need, if you've got them to hand, it's the bit of paper. Cards are good. Cards put the one side at the moment. Bit of paper, a pencil to write with, and a pack of cards. And you don't need the cards just at the moment, but they'll come along in a minute. But we'll do the number trick first.
Yeah.
I have to say it's quite a well-known trick, and so if you know it, you'll think, oh, not that again. But I hope some of our audience, the 150 of us, well, someone won't know it. So what I'm going to do is this mind reading trick. You can show this to me if you like. It doesn't really matter. But what I want you to do is to think of a 3-digit number, any 3 digits you like. And if you're working from home, please do the same thing at home. because it'll be lovely. James is writing a number down. That's lovely. Now let's see what we can do with that. Could you repeat the same digits and just make it a 6-digit number? He's smiling already. He knows where we're going with this. So now you've got
no idea.
now we've got a 6-digit number. Now I know what James's number is because I can see it on the screen. But what I don't know is I don't know what numbers. If you're playing along at home, and maybe you might give us a hint in the chat. If you're playing along at home, you might want to try it too. So I'm going to just ask you a question about this. Look at your number and look at the first, third, and fifth digits. So that's if you like the odd ones, and just add those together, and see what you get. And then can you do it for the other digits? The 4, the 1. I'm using James's screen here. The second digit, the fourth digit, and the last digit. Love the change of colour of the pen. Thank you very much for that. And add those together. Well, now, if you're doing this at home, you'll find that they both come to the same number. Rather spooky. You could have chosen any three-digit number, and yet you've managed to do that. Now, you probably will all know, I'm really speaking to you at home, probably all know that if you pick a number at random, the chance of it being divisible by something will depend really upon the number. If I said, for instance, can you divide this number by 11? Well, I've got about a 1 in 11 chance of it being exactly divisible by 11 without a remainder. And that would be fairly cool. So I either do it longhand if you want to, or pick up the calculator and take your number and divide it by 11. And what I want to see is what the answer is, and is there a remainder?
I've got a calculator at hand, which is, oh yes I have. All my calculators are in the back. There we are. Right, so I got my Casio class with, I can't remember what this one is. I should know, I'll be shouted at because people like calculators. Should be able to see divided by 11 and 148 divided by 11 is 13468. So it's divisible. It is divisible.
What, isn't that a surprise? Are you a bit
Yeah,
surprised?
I suppose so.
You're a little bit surprised. Okay. Now, I'm going to try another number. Let me think of one. I'm going to pick a prime number, 7. I'm going to have 7. I'm going to suggest that if you divide what you've got now, the number you've just got, by 7, that it will divide equally and there'll be no remainder. So if you want to try that, and those who are working along at home, try it too.
Oh, you can't see that very well. Wait, there we are. And as you can see, it does. Oh, that's amusing. That's very amusing.
Isn't that amazing? Right.
That
okay.
is.
I'm going to have one more go. I've got 2 right now. I'm going to go for another one. Let's think of another number. Let me think of. Can you divide it by 13 and see if there's a remainder?
And let me move that one up so you can see it. Oh, can you see that? Yeah. 13. No remainder.
And if you have a look at your answer, I'm hoping you've ended up with the number you started with.
148 divided by 13.
No. You should have ended up with a 3-digit number. You've got a bigger number.
Oh, am I? Oh, I'm getting confused about the instructions again. So is it 148?
You divided the first number by 11, the second number by 7, and the last result by 13.
Oh, okay. Then divide that by 13. Oh. Huh. That's wow. Oh my God, wow.
Just as a matter of interest, have you seen that before?
No, I thought you were going to go for something completely different.
Oh well, it's nice. It's nice to because you study maths and you're high up in the academic world, and so I thought you would probably know. Do you know why it works?
I'm putting my bets towards the fact about when we're doing this, probably it's divisible by 11 because the divisibility rule for 11 is the reverse,
absolutely
the
right.
digit sum. You've got to go first digit minus 1, plus 1, negative, plus 1, negative. And that's awful. So you add that one, subtract that one, add that one, subtract that one, add that one, subtract that one. And if that's 0, I believe then that's divisible by.
I'm using the rule for divisibility by 11. There's a well-known trick you can use if you sum the odd digits and the even digits in a number. If you subtract them, if it's either 0 or a multiple of 11, the entire number is multiple of 11. And so that was, but I knew it was going to be divisible by 11 before you did this. And I better explain quite what's going on. I wonder if I could ask you, because you're doing so well, if you could multiply the factors we got, 7 and 11 and 13, on your calculator and just see what they give us.
7 times 11, 13 is 1001.
And that is the secret. What happened? I've misdirected you very slightly, because when I asked you to repeat your number, what you had really done is you multiplied your 3-digit number by 1001. And so immediately I knew that whatever 3-digit number you chose, it would have the factors of 7, 11, and 13. And I'm hoping that all of you at home have enjoyed that and followed that along.
Only good things in the chat I can see.
Good. I hope they like it. Paul O'Malley says, he says.
People are getting that brilliant moment you do when you're looking at
it. It's a lovely little trick, and I do encourage you who've seen that and discovered it, do please try it on your friends and things like that, because it's great fun, and show them how it's done, because it's one of the things that are great fun. I'm going to try switching to, I've got a little desk camera here, and I'm going to try and share my screen. Let me just see if I can do this, get this ready. Hang on a second. I'm hoping this is.
You can still hear me, just can't see me.
That's right. Okay, don't worry. Got to just click a couple of buttons.
There we are.
Hang on. Where am I going? And is that working or not? It doesn't seem to be working, does it? Have I clicked the wrong button? Hang on, where's it gone? That's me. Hang on.
Hello.
Oh, it's not working. It's not working. Disaster. Hang on. What's going on? I've lost my Zoom screen, and
okay, don't worry, take your time.
It says you are sharing, but it's not sharing what I want it to share. Okay.
Do you have to go back into Zoom and say okay?
Share. I've got my IT assistant standing nearby to give me a hand if I get lost again. Just choose desktop. That's right. Click share, and it's not sharing. It's not sharing it. Okay, hang on. We'll try something.
People are enjoying the recursion. People always enjoy recursion. Recursion is fun.
Let's have a look, see if this works. Hang on. Does that?
Oh, there we are. We've got it. There we are.
That worked. Right. Okay. Now, I've got here a pack of cards. They're unusual cards, and I'm going to tip them out onto the table like that. and we'll put that pack to one side. But I want you to keep your eye on that, to make sure that doesn't go anywhere. And here I've got, these cards have got numbers on them. Which way round are we? Hang on, are we this way round?
That's supposed to be a 9.
Am I upside down the right way up?
You're upside down.
Okay, hang on, I'll turn them around. Does that work?
Yeah, I can see them brilliantly. Yeah, we don't want to see that 6 as a 9.
I don't mind doing them upside down. Okay, so you'll see here that I've got 10 cards, and this is where those who are playing along at home, and you too, James, you can do this too. You can either, well, I'll do it with you and these cards, but for those of you at home, what you can do is just take out a pack of cards. All you want is just some number cards. Doesn't matter about the suit, ace to 10. Get those ready, and then if you will play along with me, I'm going to predict the number that you're going to get. So James, can I ask you to pick 5 of these cards, and I'll push them towards you. Which would you like?
9.
You'll have a 9. Where's my 9? There's the 9. Yep.
7.
7. Yep.
3.
3. Yep.
8. Leave the 8 there. And I'll have a 1.
And a 1. Lovely, lovely, lovely. So there we go. Now I'm going to put your cards in ascending order. There we go. Now I'm left with 10, and I'm going to put these cards in descending order. So we've got 2, 6, 5, 4, 2. And what I'm interested in here is I've got to pair them up. 2, 4, 5, 6, 10, 1, 2, 3, 7, 8, 9. So what we're going to do is we're going to look at the differences between the cards. So between the 1 and the 10, I've got a difference of 9. Between the 3 and the 6, I've got a difference of 3. Between the 7 and the 5, a difference of 2. Between the 4 and the 8, a difference of 4. And between the 9 and the 2, a difference of 7. And if we want to add the sum of the differences together, so I've got 9 here, 9 plus 3 plus 2 plus 4 plus 7 is 25. Do you agree?
Yeah. I'm not very good at mental arithmetic, but I'm sure that's fine.
Okay. So
Someone in the chat will complain.
I've got 25 here. And,
Can we move the 9 a bit up? Can we see the 9?
Yeah, where's the 9? There we go.
Yeah, that's brilliant. That's fine.
Is that better?
Yeah, that's fine. Brilliant. Thank you.
Okay, so the question is, in this in this card box, I have got 1 card left, and you might be able to see if I show it to my camera there. There it is, and I'm going to take the card out, and here's the card. Are you ready? Here we go, and it is.
Oh, I love that. Oh, that's amazing. I'm going to turn on my video so you can see me shocked in my seat. Yeah. Oh, wow.
So I want to thank James Grime, because he is the person who showed me this. I was at a maths jam a few years back, and it was breakfast time, and I happened to sit on the same table as James Grime, and he pulled out bits of paper and wrote the numbers on it, and he showed me this, and I was amazed, and he didn't tell me how it worked. And so what I did, I went away and had a long ponder about it, but I'm afraid I didn't find out what the solution to it was. But I met up with him about 2 years later, and I said, James, can you tell me how you did that? And he said, oh, that's let me think a moment. That's Prosled-Cost identity. Well, I have to say, I'd never heard of Prosled-Cost identity. It's I think Katie is publishing, putting something. No, maybe something else.
Maths Jam.
And Maths Jam, that's just fine. And
we love Maths Jam.
He showed it. He said that's what it is. He said, and I said, oh, lovely. And I said to him, James, I said, you really should do a video on this. It's a really good trick. And that's what he did. So it didn't happen very quickly, but he did do one. And I'm just going to see if I can find it. I'm hoping I've got the right link. I hope this is right. Let me just see if I can put it in the chat. I'm hoping this is going to work.
Funny you speak of James Grime. We may see him coming up very soon. This is a slight teaser for what's happening. Maybe next, maybe later, but we may see James at some point. So
I'm going to quickly explain why this works. It always gives you 25. And I'm hoping this is going to work. I'm doing this upside down because my camera's the wrong way around. Can we see this? Let's have a look. Does that?
Yes, I can see that.
That's okay. One screen's lagging behind the other. It's quite unnerving.
I'm aware. But they're 30 seconds behind us, so I won't worry too much.
So what we've got here is that if you look at the numbers on the cards, in every case, every pair, you've got a big number and a small number. And that every pair is either the card, the smaller card is 5 or less, or the other card is greater than 5. And so you can write this with a bit of algebra. You've got the big one, a big 1 minus S1, a big 2 minus S2, big 3 minus S3, and so on. And if we rearrange these slightly, what you get is that you can take the big numbers. Well, we know what the big numbers are. They're 6, 7, 8, 9, and 10. And we know what the small numbers are. They're 1, 2, 3, 4, and 5. We subtract the 2, and you get 40 minus 15, which is 25. And so that's the reason it works. And I do encourage you to go and have a look at James Grime's video on that. He's done a stunning job, and he explains it in a little bit more depth than I've done. How are we doing for time?
We have 7 minutes. So have you got a treat? Do you want to plug anything? Do you want to have a chat about anything? I've got a couple of questions. If not, we can just chat about maths.
I'll do a quick plug, and then you can ask me some questions.
Yeah, of course.
As I say, I don't have great mathematical qualifications really, because I never took any. But what I did do is I wanted to write a book, and what inspired me to write it was that I found that children at school were being taught lots of useful stuff like fractions and square roots and trigonometry and stuff like that. But it seemed to me very compartmentalized, that they would be doing fractions perhaps for a few weeks and then they move on to something else. And it struck me as rather dull. And I'm sure the teachers don't intend it to be that way. Children, if you're learning maths, you do need to know about fractions. Mathematics, as you will confirm, is littered with fractions. Almost any equation you pick up is going to have a fraction in it somewhere. And so knowing about fractions and manipulating fractions is really important. But it struck me as what if I could bring the sort of whole of the syllabus together, including some trigonometry, and in one book, put all the maths you need to solve triangles. So it's got what is a triangle in there. It starts off with that. It's got going from very simple things, it goes to similar triangles, it goes to very basic trigonometry, it goes to sine formula, the cosine formula, and it also proves these things as we go along, because I think that proofs are so important. If you are told something, you think, well, that's okay. But if you're told something and then the person proves why it is so, that is a real winner. And you remember it. You think, well, I know this works. I know this works for everything that I can do. And so that's my book. It's buried very, very deeply in the Apple bookstore. And so I put a link there.
I think we've got the link. Katie's put a link in the chat. That sounds very cool. I've always wanted to write a book, and it's something I never got around to doing.
It took me a good couple of years to write it, but it's here, and it's the first 3 chapters you can download and play with if you like. If you like it, you can buy the book. If you don't like it, well, at least you've enjoyed 3 chapters. I do recommend it. And I do hope people find it of use. And you wanted to ask some questions. Ask your questions.
Yeah, just some maths questions. As I decided that filler material. We have got the link up there to donate. There's a good causes, all good causes that we're raising for, mainly for Mark Watson's charities that he's doing his 24-hour comedy show on Twitch for. And yeah, to the questions. Your favorite equation? Go on. I've asked this one before. But...
it's one a squared. It's the one that's a minus b squared. That one. I'm very fond of that one because it simplifies so nicely and you lose a term.
Difference to 2 squares.
Yeah.
If you could choose a piece of maths to discover, what would it be?
A piece of matter to discover. Well, I'd love to know whether the Riemann hypothesis is true. Unfortunately, my knowledge of maths is not sufficiently enable me to do it. I would need, I know, at least a maths degree at the very limit, and I don't have that. But I do very much hope the Riemann hypothesis is proved, because so much depends on it, and it would be a wonderful thing to have if we could achieve that.
I totally agree. And finally, I think this is kind of already covered. If you could solve any mathematical problem, what would it be? But I wanted the third question to be kind of things that are unsolved, second to the things that are solved. But we've said probably it's Riemann hypothesis.
Yeah, I think so.
Yeah, Riemann hypothesis is cool.
I can give you my favorite theorem if you like. My favorite geometrical theorem is Thales' theorem. Which I was shown in my early teens, and unfortunately we've run out of time for me to show it to you, but it's got an entry on Wikipedia and it's well worth having a look at.
I'm sure the behind the scenes people, I'm sorry I'm creating work for you, but you could always chuck it in the chat, or when I'm kind of done with my 90 minutes, I'll chuck it in the chat if people want
I'll put a link to the Wikipedia page. It's a beautiful theorem. It proves that if you draw a diameter in a circle and put a point on the circumference, you get a right angled triangle. And when I was first shown that, I thought, wow. And the proof is quite straightforward.
That's very pretty. I really like that. That sounds very, very pretty. I'm sure it's got a pretty enough proof to kind of warrant it.
So I don't know whether but we possibly are done, unless you want to talk about donate to watsonsathon.com.
Yeah, that's kind of the donation link is up there. It's in the description of the YouTube stream, which is down there, and it's for good causes. The first, I'm going to bodge this again, I'm aware. It's for the comedians that are struggling due to the COVID crisis, is one of the charities, and the second is for people in financial difficulties. I still can't find where they are in this document. I've got a document in front of me with a load of text. I still can't find it, but they're all good causes, and this is why we're doing this today. So the link is there, or the link is down below. Please donate. They're all good causes.
Well, it's been lovely talking to you. And
thank you, Simon. Thank you, greatly appreciated. Thank you for coming to share a trick. I hope you're doing well and stay to be well.
Okay. Bye for now. Cheerio.
Thank you, Simon. Bye.